Imagine a force hidden deep beneath our feet. It is a power of unimaginable scale, not a mountain that spits fire, but something far, far larger. A vast chamber of molten rock miles wide, simmering with the heat of a star. This is the heart of a supervolcano. It doesn't build a cone-shaped mountain like we often picture. Instead, it lies in wait, a colossal blister on the Earth's crust. When it finally stirs, the eruption isn't just an explosion. It is a planetary event. It is a moment where the deep interior of our world reaches out to touch the sky, and in doing so, changes everything. These are not the volcanoes of myth and legend. They are geological monsters. A super eruption is defined as an event that ejects more than 1,000 cubic kilometers of material. That is enough rock and ash to bury an entire country. How can a blast of incredible heat lead to a world of ice? The answer lies high above us, in the delicate layers of our atmosphere. A super eruption is so powerful that it doesn't just throw ash into the air. It injects enormous quantities of sulfur dioxide gas directly into the stratosphere. Up there, the sulfur dioxide reacts with water vapor. It forms a fine mist of sulfuric acid droplets. These tiny droplets create a persistent hazy veil that spreads around the entire planet. It is a global sunshade made by the Earth itself. This aerosol layer is remarkably effective at reflecting sunlight back into space. It is like placing a mirror between the Earth and the sun. With less solar energy reaching the surface, global temperatures begin to fall. It would not be a sudden dramatic drop. Instead, it would be a relentless creeping chill. A few degrees might not sound like much, but for the Earth's climate system, it is a monumental shift. The delicate balance that allows for liquid water and temperate seasons would be fundamentally broken. This cooling effect is what scientists call a volcanic winter. Summers would fail. The growing seasons for crops would shorten or disappear entirely. We know this isn't just a theoretical possibility. The Earth's geological history is a library, and its pages are written in layers of rock and ice. We can read the stories of past super eruptions and see their dramatic effects on the planet. One of the most significant known events was the eruption of Toba in what is now Indonesia, around 74,000 years ago. The scale of this eruption is difficult to grasp. It was thousands of times more powerful than any volcanic eruption in recorded history. Ash from this single event has been found across South Asia, in the Arabian Sea, and even in East Africa. Ice cores drilled from Greenland and Antarctica show a distinct spike in sulfate levels from this time. They also show that for several years following the eruption, global temperatures plummeted. This event occurred at a critical moment in our own history. Genetic evidence suggests that around this time, the human population experienced a dramatic bottleneck. Our numbers may have dwindled to just a few thousand individuals. A single geological event on the other side of the world could have almost ended the human story before it had truly begun. Now let us imagine a different future. A future where humanity is no longer confined to a single world. Let's fast forward through the centuries, to a time when we have taken our first tentative, then confident steps into the cosmos. Picture human outposts, then towns, and finally cities, established on another world. Life in a Martian city would be a marvel of engineering. The inhabitants would live under vast, transparent domes, looking out at the ochre desert and the faint, distant sun. Survival here is a constant, conscious effort. Every system, from the oxygen generators to the hydroponic farms that grow food, must work perfectly. In this scenario, Earth is the homeworld. The blue marble is a distant, cherished symbol. It's the place of origin, the cradle of all humanity. The two worlds are connected by the thin thread of spacecraft, making the long journey across the millions of miles of empty space. They are two parts of a single human story, separated by the void. The people of Mars would look up at the sky and see a different set of constellations. They would experience seasons that are twice as long as Earth's. They would live with a gravity that is only a third of what their ancestors knew. They might feel safe, separated from the geological turmoil of their ancestral home. They might believe that by moving to a geologically quieter planet, they have escaped the threat of things like supervolcanoes. But what if the greatest threat was not from the world beneath their feet, but from the world they left behind? Let us imagine the news arrives. A message traveling at the speed of light crosses the gulf between worlds. It brings tidings of a cataclysm. On Earth, a supervolcano has erupted. Not just any eruption, but a Toba-scale event, or perhaps even larger. For the inhabitants of Mars, the initial reaction might be a strange mix of sorrow, relief, and detachment. Sorrow for the homeworld, for the billions of people facing an unimaginable disaster, but also a quiet, perhaps guilty, sense of relief that they are far away, safe on their new world from the falling ash and darkening skies. They believe they are spectators to the tragedy, not participants. But they would be wrong. The effects of a super-eruption are not confined to the planet on which it occurs. The vast cloud of sulfate aerosols blasted into Earth's stratosphere would not stay contained. The solar wind and the gravitational dynamics of the inner solar system could, over time, spread a diffuse version of this sun-dimming haze across the space between planets. For Mars, a planet that is already incredibly cold, the consequences would be severe. The faint sunlight that reaches its surface would become fainter still. The average surface temperature, already a frigid -60 degrees Celsius, would plummet even further. The thin atmosphere, composed mostly of carbon dioxide, would begin to freeze. This is not a metaphor. The air itself would start to precipitate out of the sky as carbon dioxide, snow, or frost. The Ice Age on Earth would be a dynamic, violent affair. It would be a world of grinding ice sheets and howling blizzards. Humanity would be battling the elements directly. The challenge would be one of physical survival against the cold, of finding food when crops fail and ecosystems collapse. On Mars, the Ice Age would be entirely different. It would be a sterile, silent, and technological crisis. The enemy would not be the wind or the snow, but the slow, inexorable creep of falling numbers on a screen. The primary threat would be a power crisis. The colony's life support, its heat, its light, its hydroponic farms, all of it would likely depend on solar panels spread across the Martian surface. The nature of the resource scarcity would also differ greatly. On Earth, the struggle would be for the basics: food, clean water, and shelter from the cold. On Mars, the scarcity would be of energy and complex components. The colonists would have food, water, and air for a time, all produced by their systems. The crisis would emerge when a critical pump fails, a circuit board burns out, or a seal on a habitat begins to leak. Humanity's response would therefore be split along these lines. On Earth, it might lead to the fracturing of societies into smaller, more resilient tribal groups. Knowledge of farming, hunting, and basic engineering would become paramount. On Mars, the opposite would be required. Survival would depend on intense, society-wide cooperation. Every engineer, botanist, and technician would be essential. The society would have to become more integrated, more centrally planned, and more focused on the singular goal of keeping the great machine of the colony alive. On Mars, the first order of business would be to conserve power. All non-essential systems would be shut down. The vast biodomes, with their spectacular views of the darkening Martian sky, would become energy sinks, their lights dimmed or extinguished. The colony would retreat into its most efficient, best insulated subterranean sectors. Life would become smaller, more confined. The grand project of terraforming or expansion would be abandoned overnight. The new all-consuming project would be survival. The engineers would be the new heroes of this age. They would be tasked with the monumental challenge of keeping the lights on. Perhaps they would turn to alternative power sources that had been secondary before. Nuclear reactors, if the colony had them, would become the beating heart of the settlement, their steady output a lifeline in the dimming world. Every watt of power would be meticulously budgeted, every system optimized for maximum efficiency. It would be a war waged on spreadsheets and circuit diagrams. Innovation would be born from desperation. The botanists would work to breed new strains of crops that could grow under lower light conditions, or that required less energy to cultivate. Chemists would search for ways to improve the efficiency of the life support systems. The psychological toll would be immense. For generations, the colonists had looked to Earth as the vibrant, living heart of humanity. Now, it was the source of their silent peril. They would be utterly alone, a tiny flicker of life on a frozen world with no hope of rescue. This profound isolation could either break their society apart or forge it into something stronger. Their survival would depend not just on their technology, but on their ability to maintain hope and purpose in the face of a truly cosmic disaster. In both scenarios, on a frozen Earth and a darkened Mars, the disaster would act as a great filter. It would strip away the trivialities of civilization and reveal the core of what it means to be human. On Earth, survivors would rediscover a deep connection to the planet, even in its harshest state. They would learn the rhythms of the new climate, the places where life clings on. Their resilience would be physical, a testament to the endurance of the human body and its ability to adapt. The Martians, in their sealed habitats, would find their resilience in a different sphere. Theirs would be a triumph of the mind. They would be living proof of the power of knowledge, science, and collaboration. Every day they survived would be a victory for the collective human intellect that designed and built their world. They would become the ultimate librarians and engineers, preserving the sum of human knowledge not just in databanks, but in practice. This tale of two worlds highlights a fundamental duality in the human spirit. We are at once creatures of nature and creators of technology. On the ice-ravaged Earth, our more primal adaptive nature would come to the fore. On the energy-starved Mars, our intellectual and cooperative nature would be our salvation. Neither is superior to the other. They are two sides of the same remarkable coin, two different strategies for persisting in a universe that is often indifferent to our existence. Ultimately, the story of survival in the face of such a cataclysm would become the new founding myth for whatever remained of humanity. For the Earthbound, it would be an epic of fire and ice, of endurance against the odds. For the Martians, it would be a saga of ingenuity and unity, of keeping the candle lit in the deepest dark. In both cases, humanity would have looked into the abyss and refused to fall. The experience would change us forever, leaving a permanent mark on our culture, our philosophy, and our understanding of our own place in the cosmos. The thought of a supervolcano is a powerful reminder of our fragility. We build our cities and our civilizations on a thin, shifting crust, floating on a sea of fire. We are dependent on a delicate balance of atmospheric gases and a steady supply of light from a distant star. Our home in the universe is both beautiful and precarious, a safe harbor in a vast ocean, but one that contains its own hidden storms. Yet the same story also reveals our incredible resilience. The fact that we can even contemplate these scenarios, that we can understand the science behind them and imagine ways to survive, is a testament to the power of the human mind. Our ability to observe, to reason, to plan, and to cooperate is our greatest strength. It allowed our ancestors to survive the last ice age. It is what drove us to understand the workings of our planet, and it is what might one day allow us to carry the seed of life and consciousness to other worlds. We are fragile, yes, but we are not helpless. Thinking about cosmic-scale disasters isn't about succumbing to fear. It is about fostering a sense of perspective and wonder. When we look up at the night sky, we are not just seeing distant points of light. We are looking out into a universe of incredible energy and scale, a place of both creation and destruction. Understanding the threats, like supervolcanoes or asteroid impacts, encourages us to become better stewards of our own world and more ambitious explorers of what lies beyond. Our existence is a brief, brilliant flicker in the grand timeline of the cosmos. We are the universe made aware of itself. We have the privilege of being able to ask these questions, to look back at the history of our planet, and to look forward to the potential of our future. Whether we face the challenges to come on this world or on another, the human spirit of inquiry and survival will be our guide. The universe is vast and often dangerous, but it is also our home, and the quest to understand it and our place within it is the most noble journey we can ever undertake.